So this is 1405, and I'm going to do problem number 4, which looks like this, okay? And the idea behind this, once again, is not to get too confused, because you're just going to make it similar or smaller or easier as you go, all right? So first of all, you start off with the RAV table, okay? And then I'm going to go ahead and start listing my resistors, and as I will list them, sorry for the wobbly line, I'm going to think of how I'm going to pair them. So R1's by itself, then I'm going to go R2, R3, and then I have to make a comparable R2, 3 resistor. This will be on the outer loop, he'll be on the outer loop. The next one I go is R4, R5, then I'm going to go one for him, R4, 5, and then I'm going to have just our total, okay? So let's just start filling this in. 4, and this one's 3, and this one's 6. So I can go 1, 3 plus divided by 1, no, I'm sorry, 1/3 plus 1/6 is equal to, I'm going to use my calculator, because why not? That's why they were made. 1 divided by 3 plus 1 divided by 6 gives me a number of 0.5. So 1 divided by that would be 2. Simple, right? So I have R4 being 6, and this being 6, right? So I'm going to have 1/6 plus 1/6 equals 2/6. Take the reciprocal, that would be 3. So I put 3 for this one. Let me count my outer length. 4 plus 2 is 6, plus another 3 is 9. So it's 24 volts total. So next thing is 24 divided by 9 gives me 2.67. Okay? Now, because these things are in series, the outer ring, because it really looks like this now, it's going to be 24 volts, R1, R2, 3, R4, 5, and then it goes back around. That's series. So I can move up the amps. 2.67 here, 2.67 here, and 2.67 here. These are easy. I just multiply across. 4 times 2.67, I get the number 10.68. Or I can say 10.7, right? 2 times 2.67, I get the number 5.34. And the next one is 3 times 2.67, you get the number 8.01. So now look, because it's parallel here, I got to move volts up. So I'm going to grab this guy, I'm going to move him up to here. And this one, I'm going to grab this guy, and I'm going to move him up to here. So 5.34 for this guy, and 5.34 for this guy. You see why it's in parallel. I got to move something. I can't move amps, because that's not what stays the same. Volts does. So now it's 5.34. I just divide it. Let's start from the top down. 5.34 divided by 3, I get the answer 1.78. Okay? I have 5.34 divided by 6, I get 0.89. If you were to add these two together, you would get 2.62, right? Or 67, I think that's what that is. Let's do this guy. So I put 8.01 here, and I put 8.01 here. Okay, so 8.01 divided by 6, I get the number 1.34. This would be the same, 1.34. So if I total it, it comes up about 2.67. That's how you do this kind of a problem. Okay, so that's problem number 4.